In March of 1955, a telegram arrived at Albert Einstein's home in Princeton, New Jersey. It carried news that stopped him cold. Michel Besso, his oldest friend, his thinking partner of more than 50 years, was gone. Now, if you've never heard that name before, that's actually part of the story. Besso wasn't the kind of physicist who ends up on the cover of magazines. He didn't have a famous equation named after him. But here's what he did have. He had Albert Einstein's trust in a way that almost no one else on Earth did. When Einstein had an idea still too raw and shapeless to show the world, when it was still just a strange pressure behind the eyes, a feeling that something important was hiding just out of reach, Besso was the person he called. The two of them would walk the cobblestone streets of Bern, Switzerland for hours, talking, arguing, circling the same problem from every angle, the way you circle something you can almost see in the dark, moving around it, trying to catch it from a different direction, hoping the next step brings it into view. And in 1905, when Einstein published the paper that would permanently change how humanity understands the universe, the special theory of relativity, there was exactly one person he thanked. Just one. Michele Besso. So when the telegram arrived that March, it wasn't just the loss of a friend. It was the loss of the person who had been present, in a real and irreplaceable way. At the moment, Einstein changed the world. A few days after Besso's death, Einstein sat down and wrote a short letter to Besso's surviving family. And buried inside that letter was a single sentence that has been quoted in physics classrooms, debated in philosophy journals, and whispered in late-night conversations among scientists for 7 decades since. Einstein wrote, "Michele has preceded me a little by leaving this strange world. This means nothing. For us believing physicists, the distinction between past, present, and future is only a stubbornly persistent illusion. Only a stubbornly persistent illusion." Now I need you to notice something about that sentence. Because it is very easy to read it as a grieving old man reaching for comfort, looking for something, anything, that might take the edge off an unbearable loss. But that's not what's happening here. Einstein was the last person on Earth who would reach for a convenient untruth. He had spent 50 years disciplining himself to follow the equations wherever they led, even when they led somewhere that made no intuitive sense, even when the conclusion felt strange and uncomfortable, and unlike anything human beings had believed before. What Einstein wrote in that letter was not a comfort. It was a precise technical claim about the structure of physical reality, one that follows directly from the mathematics he had spent his whole life building. Today, on Feynman's path, we are going to follow that claim all the way down. We're going to start with the physics, with what Einstein actually discovered in 1905, and work our way toward what it means for the moments you have lived, the people you have loved, and the ones you have lost. I want to give you a fair warning before we go there. This will feel strange. Parts of it will feel genuinely uncomfortable. The physics we're going to discuss has a way of undercutting assumptions so fundamental, so deep in the structure of how you experience being alive, that you may not have even known you were making them. But I promise you this, by the end, the strangeness transforms. It doesn't resolve into something easy or simple. The physics doesn't hand you easy answers. But it resolves into something honest. And something about honesty, especially honesty about things this large, has a way of feeling, in the end, something like peace. Let's begin. Right now, as you listen to this, you are moving through time. The moment I just spoke is already behind you. The next word I'm about to say is still ahead. Yesterday is locked in the past. Tomorrow hasn't arrived. The people you've lost feel genuinely gone the way a city disappears in the rearview mirror as you drive away, receding, gone, no longer part of the world you're in. This feeling is so powerful, so constant, so completely saturating every second of conscious experience, that calling it a feeling seems wrong. It doesn't seem like a feeling. It seems like pure, unmediated, undeniable fact. Time flows forward. The past vanishes. The present is all we ever actually have. Here is something about this certainty, this rock-solid, bone-deep certainty about how time works. It does not appear anywhere in the fundamental equations of physics. Not once. Not in any of them. Consider what I mean by that. When physicists sit down and describe the laws of nature, the actual rules governing how particles move, how forces work, how energy transforms, they write these rules as mathematical equations. And those equations have a remarkable property. They work equally well in both directions of time. Isaac Newton's laws of motion, the ones describing how objects push and pull each other through space, are completely time reversible. If you filmed any system obeying Newton's laws and ran the film backward, the physics would still be perfect. Nothing would break or violate any rule. James Clerk Maxwell's equations for electromagnetism, which explain light, radio waves, and the fact that electricity flows through your walls time-symmetric. Erwin Schrödinger's equation, governing the quantum behavior of atoms and electrons time-symmetric. And Einstein's own equations of general relativity, the most precise description of gravity and the curvature of spacetime we have ever produced, also completely time-symmetric. Every fundamental physical law ever discovered by human beings. Not one of them builds a direction into time. So here is the first genuinely strange question we need to sit with. If the laws of physics don't distinguish between past and future, if the equations that describe reality at its deepest level are perfectly indifferent to the direction time flows, where does the overwhelming, inescapable, absolutely certain feeling that time only moves forward actually come from? This is not a trivial question, and the answer is not what most people expect. To get there, I need you to picture something very ordinary. You're in a kitchen. There's a glass of water sitting on the counter. It gets bumped off not even hard, just a little nudge, and it falls to the floor and shatters. Glass everywhere. Water spreading across the tile. Now imagine watching that film in reverse. The scattered glass shards slide back across the floor toward each other. They reassemble seamlessly and perfectly into an intact glass. The water leaps upward from the tile. The glass rises through the air and lands precisely where it had been sitting. You know instantly and completely that this never happens. You didn't need to think about it. Some part of your brain just said no. But here's the real question, the one that cuts deeper than the obvious answer. Why not? The atoms in those glass shards obey Newton's laws, and Newton's laws are time reversible. There is no physical law that says glass shards cannot reassemble. So why don't they? The answer is probability. Pure, statistical probability at an almost incomprehensible scale. That glass sitting intact on the counter can exist in essentially one configuration, one precise arrangement of its molecules that constitutes a whole, functional glass. But the state of shattered glass scattered across a kitchen floor can be achieved in an astronomical number of different ways. Different fracture patterns, different positions for each of the hundreds of shards, different angles and velocities for the scattered water droplets. Billions upon billions of possible arrangements, all of which look like broken glass. And here is what physics tells us. Systems evolve toward the states that can be realized in the greatest number of ways, simply because the statistics overwhelmingly favor them. The intact glass can only be intact in essentially one way. The broken glass can be broken in essentially infinitely many ways. The drift from organized, improbable states toward disorganized, probable ones, this tendency is what physicists call the increase of entropy. Now here is the crucial thing, the thing I want you to hold on to as we go deeper. This is not a fundamental law in the same sense as Newton's equations or Einstein's equations. Entropy's arrow is a statistical law. It describes the collective behavior of enormous numbers of particles, and it operates in one direction from order toward disorder, not because of anything written into the bedrock of the universe, but because we happen to have started at the Big Bang in an extraordinarily low entropy, highly organized state. The forward direction of time that you feel as absolutely, viscerally, undeniably real, that is, at its deepest roots, a statistical phenomenon, an emergent property of large systems, not a feature built into the fundamental equations, not carved into the bedrock of the universe. Richard Feynman spent years thinking carefully about exactly this question, the relationship between the fundamental time symmetry of physics and the obvious irreversibility of daily experience. Feynman was allergic to confused thinking, and he pointed out, with the directness that made him famous, that there's no actual contradiction here. At the level of individual atoms, physics is reversible. At the level of trillions of atoms behaving collectively, the sheer weight of statistical probability creates a direction that feels absolute and inevitable. Feynman loved this kind of thing, when apparently paradoxical situations resolve cleanly once you think about them at the right level. And what he understood here is that the most powerful feature of human experience, the forward march of time, is something that emerges from statistics, not from fundamental physics. And once you see that clearly, a strange door opens. Because if the arrow of time is statistical rather than fundamental, if the laws of physics at the deepest level don't require time to point in any direction, then what does the universe actually look like? At the level of the equations themselves, when you strip away the statistical machinery that creates the arrow we experience, let me approach this from a different direction. Think about where you are right now. Some room, some physical location. You're here, at this moment. An hour from now, you'll probably be somewhere else. But the fact that you'll be elsewhere in an hour doesn't mean this room is going to stop existing. The room will still be here, at its location in space, whether or not you're in it. Your departure doesn't create an absence in the room. The room simply continues to exist at its coordinates. This seems too obvious to bother saying. Of course the room will still be here. Of course your living room doesn't cease to exist when you go to the grocery store. But notice, we don't apply this same logic to time. We think of a moment in the past as something that happened and then stopped happening. The moment is over, which means we assume, without even recognizing it as an assumption, that the moment is somehow gone, vacated, empty. As if events in time were temporary occupants of a location that empties out when they leave. But why would that be true? Why would the logic that works perfectly for locations in space places don't stop existing when you leave them not apply equally to locations in time? This is the question Einstein's physics answers, and the answer is strange. In 1905, Einstein demonstrated something that overturned one of the deepest assumptions in the history of human thought. Time is not the universal background that everyone had assumed. There is no single cosmic clock ticking at the same rate everywhere, marking off seconds that are the same length for every observer. Time is not the backdrop against which events happen. Time is woven into the fabric of space itself, one more dimension of the physical world, affected by motion and gravity just as space is. Two people moving at different velocities experience time at different rates. A clock on a fast-moving rocket ticks more slowly than an identical clock sitting still on the ground, not because of any mechanical difference in the clocks, not because of vibration or temperature or any physical effect on the clock's machinery. The actual passage of time, the literal ticking of the fabric of space-time, is slower for the moving clock. In 1971, two physicists named Joseph Hafele and Richard Keating tested this directly. They put extremely precise atomic clocks on commercial airplanes and flew them around the world. When the planes landed, they compared the airborne clocks to identical clocks that had stayed on the ground. The clocks disagreed. By exactly the amount Einstein's equations had predicted 66 years earlier with nothing but mathematics. Time passed at different rates on the plane and on the ground. And this is not a laboratory curiosity. GPS satellites, the ones your phone uses every time you check a map, experience time at a different rate than clocks on Earth's surface because of their speed and the weaker gravity at their altitude. Engineers correct for this effect every single day. If they didn't, the location data your phone receives would drift by miles within hours. Einstein's relativity of time is embedded in the infrastructure of daily modern life. So, if there is no universal clock, if every object and person and particle has its own local time, if there is no single cosmic present ticking away simultaneously for everyone, what does it even mean to say an event is in the past? This is where Einstein's mathematics leads somewhere genuinely surprising. Einstein unified the three dimensions of space with the dimension of time into a single four-dimensional structure called spacetime. In this structure, events don't occur and then vanish. They exist at coordinates fixed, permanent, specific coordinates the way cities exist at coordinates on a map. The mathematician Hermann Weyl, one of the deep thinkers working alongside Einstein in the early 20th century, stated the implication with unusual directness. The objective world simply is. It does not happen. The objective world simply is. Not was, not will be, is. All of it. Every event that has ever occurred in the history of the universe, every moment that anyone has ever experienced, fixed at its coordinates in the four-dimensional structure of space-time, as permanent as the structure of the equations themselves. This view is called eternalism, or the block universe, and I want to be absolutely precise about what it is. It is not a metaphor. It is not a spiritual interpretation. It is not a poetic way of saying memories keep the past alive. It is the most natural, mathematically consistent reading of what general relativity actually says about the structure of physical reality. Einstein believed it. The physicist who perhaps understood general relativity most deeply after Einstein, Roger Penrose, has written about it extensively. It follows from the equations in a way that is very difficult to dismiss without adding additional assumptions that the equations themselves don't require. What it means for ordinary life is difficult to fully take in. The moment you were born, that precise configuration of physical reality, that exact instant is at its coordinates in space-time, not as a fading memory. Not as a photograph of something that no longer exists. as a location in the four-dimensional map of the universe, as present in the structure of reality as the moment you are in right now. The first time someone looked at you with complete love. The last morning you woke up next to someone who is no longer alive. The afternoon you sat in a particular kitchen with particular light coming through a particular window, drinking coffee, not knowing it would be the last ordinary afternoon before everything changed. These are not ghosts, they are not echoes, they are not traces, they are coordinates. They exist. Right now, in the universe as physics describes it, they are as real as anything else that is real. You cannot reach them. Entropy is pushing you relentlessly forward, and the geometry of space-time does not permit the journey back. But there is, and this is the thing I need you to hear clearly, a profound difference between you cannot reach something and it does not exist. Chicago exists right now. You may not be in Chicago. You may never have been to Chicago. That doesn't matter. Chicago is at its coordinates, full of its millions of people and buildings and streets and ordinary days. Your absence from Chicago creates no vacancy at Chicago's location. Einstein's physics says the same logic applies to time. The moment is not vacated when you move past it. It remains at its coordinates. The universe does not delete its own history. Now here is where I want to slow down, because this is the point where this idea either becomes genuinely transformative or collapses into something that sounds nice but doesn't connect to anything real. You might be thinking, fine, if that's all true, it still doesn't change anything about the experience of loss. I still can't have a new conversation with the person I've lost. I still wake up and they're not here. The coordinates being technically real somewhere in the four-dimensional block doesn't change what I actually live with every day. And you're right, the block universe doesn't give you back the living relationship. It doesn't restore the stream of new mornings and new conversations. It doesn't close the gap that grief opens in daily life. But here's what I think it does do, and this matters. It changes the ontology, the basic story about what happened, because when we use the word gone, when someone dies, when we lose someone, when something ends, we use that word with a specific image attached to it. Gone means erased. Gone means reduced to nothing. Gone means the space they occupied has been vacated, emptied, cleaned out, the way a room is cleaned out when someone moves away. And what Einstein's physics says clearly, mathematically, without any sentimentality or wishful thinking, is that this image is simply wrong. Not wrong in a comforting way. Wrong in the way that the sun goes around the earth is wrong. Wrong in a way that more careful attention to reality has overturned. The person didn't leave and leave nothing. The person is at their coordinates. Every moment of their existence, every conversation, every expression, every ordinary morning is at its coordinates in the four-dimensional structure of space-time. The universe does not have a delete function. There is no recycle bin in the geometry of space-time. What happened is that you moved forward. Entropy carried you. And there is an enormous, I want to say that again, an enormous difference between they are gone and I have moved forward while they remain at their coordinates. Those are not the same description of the same event. They imply different things about the universe. And physics, at least according to the most natural reading of the equations, sides with the second description. I'm not saying this removes grief. Grief is real, and it is about something real. The loss of new mornings, new conversations, new moments, the living future of the relationship. That loss is genuine. It doesn't require minimizing, but the archive is intact. The coordinates are occupied. The past is not nothing. Let me take this one level deeper, because we haven't yet talked about why grief feels the way it does from the inside, and the physics of that is just as strange and just as illuminating. Your brain is a physical system. It obeys the laws of thermodynamics, and one of the things entropy does, as it drives systems from organized to disorganized states, is leave physical traces. A burning candle leaves ash. A river in flood leaves silt on its banks. A life being lived leaves physical marks encoded in the precise architecture of your neural connections, in the synaptic weights and protein structures that make up the material substance of your memory. You remember the past and not the future for the same reason broken glass doesn't reassemble. The past has happened, so it has had time to inscribe its effects into your physical structure. The future hasn't happened yet, so it hasn't left any marks. Memory is entropy's fingerprint on the brain. And here is what that means for why loss feels the way it feels. While someone is alive, something specific is happening in the information processing structure of your brain. New data is constantly arriving. Every day brings new conversations, new expressions, new events, new input that updates and extends and refines your brain's model of who that person is. The relationship is not static. It is a living, dynamic, constantly refreshing process. A stream of new information, always arriving, always updating the picture. Then it stops, all at once. The channel closes. The stream is cut off. What was a dynamic, ongoing process, always growing, always extending, becomes fixed. The last update is the last update. No new conversations to add. No new expressions to record. No new ordinary moments. And your brain, which is built, evolutionarily, to detect change, to track what is moving and what has stopped, to monitor the streams of information flowing in from the world, experiences this cessation as a wound. Because something that was moving has gone still. Something that was alive in the precise information processing sense of being a source of continuous new input has stopped. This is why the photographs matter so much. Why the voicemail you can't delete still gets played. Why the chair still shaped by years of someone's presence can stop you cold when you walk past it. These are the physical artifacts, the material residue of a life that moved through entropy and left its marks everywhere it went. They are evidence. They are proof. Someone was here. And your brain keeps returning to these traces, keeps reaching toward the stream that has been cut off, keeps running the same search. What is new? And finding, every time, the same answer. Nothing. The stream has stopped. This is grief, described from the inside of the physics, not a flaw in the system, not irrationality. The system doing exactly what it was built to do, maintaining an accurate model of the world in the face of an event that cannot be metabolized by ordinary updating. And what physics offers here is not a cure for grief. It is a more precise description of what grief is actually responding to. The grief is about the stream having stopped, not about the archive having been deleted. And those are very different things. Let me now turn the lens in a direction we haven't looked yet. Because we've been considering what this means for the people you've lost. But it applies just as fully to you. Every version of you that has ever existed is at its coordinates in space-time. Let me say that again. Every version of you. The child you were at 5 years old, in whatever room you were in, thinking whatever thoughts you were thinking. The teenager. The young adult making mistakes you still wince about years later. The version of you on the worst day of your life so far. The version of you on the best one. The version of you who made the decision you most regret. The version of you who experienced something so good it has set the standard for everything since. All of them exist at their coordinates, not as memories dissolving into neural noise, not as increasingly unreliable reconstructions, as locations in the four-dimensional structure of the universe, as present and real as the version of you that is listening to this right now. You, the self you feel yourself to be, this moving point of experience navigating through the present are, in the block universe, a four-dimensional object, an extended structure in space-time. The complete arc of your life, from first breath to last, is a single coherent thing in the geometry of the universe, not just a series of moments, a shape. Feynman developed a way of thinking about physics called the path integral formulation, which calculates what happens to particles by summing over all possible paths through space and time. The whole trajectory matters, not just where something is at any given moment. And I find that something like this is also the more honest way to see a life. Not just the current position, the full shape, the complete arc, which is real and permanent in a way that the moving tip of moment-to-moment experience can't fully appreciate from inside it. You are not just where you are right now. You are the full shape of where you have been and where you are going. And that full shape is real and cannot be erased. Now, before I close, I want to be honest with you about the limits of what physics can claim here. The block universe is the most natural interpretation of general relativity, but it is an interpretation. The equations describe mathematical relationships. What those relationships mean for the ultimate nature of existence, for what it means to say something is real, for whether past moments have the same robust existence as present ones, these questions run into deep philosophical territory that mathematics alone cannot settle. There are physicists who read the same equations and reach different conclusions. There are interpretations where the present moment has a special status, where the future is genuinely open, where the block universe picture is too strong a claim to make from the mathematics. I am not in a position to tell you the block universe is definitely, certainly, finally correct. What I can tell you is that it follows quite naturally from the equations. that Einstein held it, that many of the physicists who have understood general relativity most deeply have held it, and that the alternative, the common-sense picture of time as a river, carrying everything away into nothingness, is very hard to maintain once you actually look at what the equations say. And I think there is something worth holding on to even in the uncertainty. Because the deeper you go into physics, the harder it becomes to believe in the naive picture of the past as simply gone. The equations resist it. The structure keeps pushing back. Time is stranger and more flexible and less destructive than it feels from inside the ordinary human experience of it. Feynman would say, "I think it's much more interesting to live not knowing than to have answers that might be wrong." He was talking about quantum mechanics, but it applies here. We don't know, with certainty, what the block universe means. We don't know, with certainty, whether past moments being real at their coordinates means there is any experience associated with them. These are questions at the edge of what physics can reach. But they are interesting questions. And the honest engagement with them leads somewhere different, somewhere more precise than the default picture of the past as a void. 5 weeks after writing that letter to Besso's family, Einstein took his last breath. The 18th of April, 1955. At 1:15 in the morning, in a hospital room in Princeton, New Jersey. There was a nurse present who heard him say something in German, his native language, but she didn't speak German, and so the final words of one of the greatest minds in human history were not recorded. The last thoughts of Albert Einstein remain unknown. But what is not unknown is what he built. The equations that describe the geometry of spacetime. The framework inside which every event that has ever occurred is, if the equations are taken at face value, permanently inscribed. If the block universe is right, then Einstein's coordinates are fixed now too. Everything he ever thought, every equation he ever wrote. Every conversation he had with Besso on those long walks in Bern, searing the idea that would become special relativity, at their coordinates, permanent, in this structure of the universe that his own equations described. He knew this. He had known it for 50 years by the time he sat down to write that letter. And I think, though he didn't say it in these words, that he wanted Besso's family to know it too, not as a comfort that smooths over the reality of loss, as a fact. As the most precise, most mathematically grounded description of what had actually happened that anyone, anywhere had yet found a way to say, "Michele has preceded me a little by leaving this strange world." This means nothing. There's a question I haven't asked yet, and it's one I think you may already be circling, because we've established something quite strange. That the laws of physics don't build a direction into time, that the arrow comes from entropy and statistics, that past moments exist at their coordinates in the block universe. But there's a question that hides underneath all of this that I haven't directly confronted. And it's the question that, when you really follow it, leads somewhere even stranger. The question is this: if all moments of time exist equally, if past, present, and future are just coordinates in a four-dimensional structure, then why is there a now? Why does one moment feel like the present while others feel like past or future? If the block universe is really the right picture, what explains the sense of moving through time? What is doing the moving? This is one of the deep, unresolved questions at the intersection of physics and philosophy of mind, and I want to be honest with you about the fact that it doesn't have a clean, settled answer. But the directions physics points are themselves fascinating. One possibility, and it's the one that a lot of physicists and philosophers who take the block universe seriously have explored, is that the sense of moving through time, the experience of now, is something that consciousness generates. Your brain is a physical system that processes information in a particular sequence, updating its model of the world based on the entropy-driven flow of new data. And what you experience as the present moment may be precisely that. The leading edge of the information processing, the point where new data is being integrated into the brain's ongoing model of reality. In other words, you don't move through time. The now is generated moment to moment by the process of your brain doing what brains do, integrating information, updating models, maintaining a coherent picture of what is happening in the world. From inside that process, it feels like forward motion, but in the structure of space-time itself, there is no moving. There is just the four-dimensional shape of your life, complete from birth to death, existing at its coordinates. This is deeply strange, I want to acknowledge that. The idea that the feeling of moving through time is something your brain produces, rather than something that corresponds to actual motion through a pre-existing dimension, is genuinely disorienting. Most of us experience the sense of temporal passage as one of the most fundamental, non-negotiable facts of existence. The idea that it is in some sense a construction, an artifact of how physical systems that process information experience themselves, takes some sitting with. But here is why I find it not merely interesting but important. If the experience of now is something the brain generates rather than something that tracks a special feature of the universe, then what follows is this: every moment, for every conscious being, had the quality of now while it was being experienced. Your 5-year-old self, in their present moment, was experiencing exactly what you are experiencing right now, the full force and presence and immediacy of being here in this moment. That quality of presence, of nowness, was not diminished by the fact that it was 50 years ago. From inside that moment, it was everything, the present, the full, complete, immediate presence of being alive. And Feynman noticed something like this in the way he thought about his own life. He was famously direct about mortality. He had been diagnosed with kidney cancer in his 50s and was given a few years, and he faced it with a kind of clarity that was characteristically his own. He talked about the fact that the fear of death often involves imagining a future absence, a state of non-existence that you will somehow experience. But he pointed out, quite simply, that you won't experience non-existence because experience requires a functioning brain, and the cessation of that brain is precisely what death is. There is no subject to experience the absence. And in the same vein, the moments that have passed did not somehow become less real when you stopped experiencing them. They were fully real when they were present. That quality of reality was genuine and complete. I keep returning to a particular image when I think about this. Imagine a long piece of film, the old kind, transparent strips with images on each frame. Every frame exists simultaneously. All of them are present, physically, in the roll of film. But when you run the film through a projector, only one frame is illuminated at a time, and that's the frame that appears on the screen, large and vivid and present. The block universe is like the full roll of film. Every frame exists. Every moment is there, in the physical structure of the four-dimensional spacetime. What we experience as the present is like the light in the projector. It illuminates one frame at a time, and from inside the experience of that light, the illuminated frame feels like the only one that exists. The other frames seem dark, past, gone. But the frames are still there. The film hasn't been cut. Nothing has been removed. Now, I want to look at something that I think is the most emotionally resonant implication of all of this. And it's something that requires going back to the relationship between entropy and memory. We said that you remember the past and not the future because the past has inscribed itself into your physical structure. Your brain carries the marks of what has happened, and the future hasn't happened yet, so it has left no marks. Your memories are the physical residue of entropy's passage through time. But here's something remarkable about this. Your memories of someone who has died, those specific, personal, irreplaceable memories, are not just records in your brain. They are part of the permanent physical causal chain that connects the past moments of that person's life to the present structure of the universe. That person existed. Their existence caused things to happen in the world, in other people, in you, and those effects ripple forward through time, as causal chains always do, inscribed in the physical structure of everything they touched, including your brain, including the people who loved them, including, in ways that are often impossible to trace but are nonetheless real, the entire causal history of the universe from that point forward. This is not metaphorical. Causality is fundamental. Every event that occurs leaves physical consequences that propagate through time. And every life that was lived, every person who thought thoughts and spoke words and touched other lives is woven permanently into the causal fabric of everything that follows. The person you lost is not at the beginning of a chain that ended when they died. They are threaded through everything that has happened since, in ways that are often invisible but are as real as gravity. You carry them in your neural structure. The people who knew them carry them too. The decisions that were made because of them, the people who exist because of them, the ideas that spread from them, all of it propagates forward through time, part of the permanent causal history of the universe. I am not saying this to minimize the loss. The specific, particular, irreplaceable presence of someone, their voice, their expressions, the way they move through the world, that cannot be substituted for or replaced by abstract talk of causal chains. Grief is not solved by physics, but physics does say something true here, something that is easy to miss when grief is fresh and loss feels total, which is that gone, in the absolute sense of no longer having any reality, no longer mattering, no longer being part of the universe in any form, is not what happened. It is not what death is. The person is woven into the causal structure of everything that follows. The moments of their existence are at their coordinates in space-time. The physical effects of their life propagate forward in ways that cannot be undone. The universe does not perform acts of erasure. It simply continues, carrying everything that has happened into everything that follows. And this, when I sit with it, feels like something important. Let me close with just this. At some point in your life, I suspect, you have had the experience of remembering something from years ago and having it feel, for just a moment, almost present. Something triggered it, a particular smell, a certain quality of afternoon light, a piece of music, and for that second, the remembered moment didn't feel like a memory. It felt like somewhere you could almost reach, like it was just on the other side of something very thin. Physics would not endorse that feeling as literally true. You cannot actually go back. Entropy prevents it, and the geometry of space-time makes it impossible. But the intuition, the sense that the past is somewhere rather than nowhere, that it has some kind of substance rather than being simple emptiness, that intuition is pointing at something the equations support. Every morning you woke up next to someone you loved. Every room where you felt completely at home. Every conversation that ended before you were ready for it to end. Every version of yourself that you have grown past and left behind as entropy carried you forward. Still there, at their coordinates. In the permanent, unchangeable, four-dimensional structure of a universe that does not erase its own history. The stream of new updates may have stopped. The channel may be closed. The grief of that is real and undeniable and does not need to be argued away. But the archive is intact. The coordinates are full. The moments are not nothing. The universe, in its cold and precise and somehow beautiful way, keeps its records. And somewhere in the structure of space-time, at coordinates now fixed and permanent, an old man in a house in Princeton is still sitting down to write a short letter. Outside the window, early spring is beginning. And somewhere in Switzerland, on cobblestone streets that are also still there, two young physicists who have just changed how the universe understands itself are still walking and talking and alive. Thank you for spending this time thinking carefully about things that are genuinely hard to think about. That is what Feynman's path is here for. I'll see you in the next one.